Welcome back to Learning C. Now, this is Sizeof operator. That is what we want to do in this class. Still on the framework, my 13 framework, manifestation in reality. If you have seen that video or if you have not seen that video, please go and check it out. How will we know the size we are going to allocate to any data type or to any variable, right? That is what this operator does, Sizeof operator. So this operator helps us to see the size we have allocated to a particular type of variable that belongs to a data type. So what we want to look at is Sizeof operator. Sizeof operator. Now, if I declare a variable and I say size of A, I'm simply saying, tell me the landmass that you have given in the memory to occupy this variable, right? That is what it is. So I'm going to write my source code, and then I'm going to call this Sizeof operator to tell me the size that have been allocated to a particular type of variable. Now, it is not the variable in itself that has that size. It is the data type. So whichever data type that variable belongs to, that is the size that will be allocated in the memory space to carry the value. You know, we did assignment operator in the last class. So this assignment operator is assigning literal value to a variable. Now, this variable belongs to a data type. Now, this data type has to be given a space in the memory, which is what? The landmass, the physical space. Just like this Earth. Depending on the type of company, will now determine the landmass that we are going to allocate for you to build that company. If it is a school, what is the size of the school? The landmass will determine the landmass we allocate. So how to know that landmass in the physical space? We are going to call this operator to do that job for us, right? So let's write a small source code, and then we'll run it on our code blocks, and then we'll see the value that will be given. So let's do that. So I would say include stdio.h. This is our preprocessor directive, which from this we are going to get the printf function that we are using. So for those that have been following me, you already know why we simply include this when we are writing. All right. Then here I have my int main function. Don't worry, when we get to function as a topic, I will now really explain to you why we are always having this main. Let us make man in our image. That in our image is this main. Every other thing you are going to create will be in that image. Now, in the beginning, he created heaven and earth. In the beginning, so man was made in their image, not in the beginning. So that is always what we are doing. So it's like saying in the beginning. So in main, but this one is integer, because this main is always going to return an integer value. And that is what we usually return, which is what? Return 0. We are returning back to the calling OS, the operating system, to say I've finished the assignment. So that's why we are always bringing this main. It is in this main everything is going to take place. So we have said int main. Then inside this main, I am going to declare my variable int a, right? And then I will declare another variable int b. This one is int a. This one is char b. Then this one is let's do double c. All right. So I have created 3 variables. This is a, this is b, and this is c. But this a belongs to the integer realm. This B belongs to the character rem. This C belongs to the double rem. I am going to call this size of operator to tell me the size of the memory that will be allocated for this, and for this. So I will come to my what? My print function, printf, right? Then here I will say size of A. Then I'm going to call my format specifier. Here I'm going to use LU. This is LU, which is unsigned long. Why am I using this? Why am I not using this? Why am I not using this? Which is D. The reason why I'm not using this is because this size of operator is going to return size T. Is a data type that is in the unsigned realm of integer. So that's why I'm using this unsigned long, because for some system we have 64-bit system. So it's going to be huge. If you use this, you might probably have issue. But you can equally use this. But this is returning size T, which is what? Unsigned integer. That's why I'm using this format specifier, LU, unsigned long, right? So I'm using this, then I will put my new line, then I'll close this, and then I'll put this comma. So for this, I'll call my size of, and then I'll say A, and then I'll close this. So I'm calling the size of operator, and I'm saying, tell me the value of the memory space that will be allocated to this variable. But it is what? Integer. So it is the data type that is determining that. So even if I change this one to integer, this B will also return the same value, right? So that is for that. Then for this, I'll say printf size of B. Then I'll do this LU. I'll do this. Then I'll call my size of operator. Here I'll say printf size of C. Size of C. Okay, so these are my variables that I've declared. Then I can equally do something here too. I can introduce another data type. Is a derived data type, which I'm going to teach you when we get to it. Is what? Structure. So struct data, right? I'm going to do this. Now, this struct data, inside it, I will say int A, and then I will say double C. Then I will close this. Then I will close this. Now, this is what I have written. This thing, I should have written it here, but because of the space. Now, if I want to print out, so this one, I can write it here, right? If I want to now print out the size of this struct data, is a derived data type. This is just like saying this one is the primary data type, which is what? This integer char double. It's like saying you build a bungalow and then you are building a skyscraper or 5-story building. So you have the first floor, then the second floor, the third floor. For this one, you can have maybe the first floor is a school, the second floor residential. The way they are designed are different. If you have seen my lecture on SQL, this is more or less like a table. You know, a table has many columns. A table has right? This one column, this another column, this another column. This can be a different data type. This one a different data type. This one a different data type. So this struct is like that. So this first column can be this A. This C can be this column. So a struct is like that. It's a derived data type from the primary data types. Now, if I want to know the size, I'm still going to teach you this struct. If I want to know the size of this struct data type, I'll come here and I'll say print f size of struct data, right? Long U n. Then I will say size of struct data. I will stop here. So I can say return, right? 0. So what will be the value of this when I print it out? When I run this, when I run this on my code blocks, what do you think the value of this will be? Now, the value of integer, depending on the structure of that system, right? For my own system, I'm using a 64-bit system. Now, this integer will give me 4 bytes. This one will give me 4 bytes. This will give me 4 bytes. This one will give me 1 byte, right? Then this double will give me 8 bytes on my system, right? Now, this struct, which is this one, so this one will give me 4, this one will give me 1, this one will give me 8. This struct will give me, integer is what? 4. It's going to add them up. So integer is 4. This one is 4 bytes, this one is 8 bytes. So this one will give me 12 bytes, right? This one will give me 12 bytes. But if you run it on my system, which is a 64-bit, depending on how the CPU is structured, this one can give me 16 bytes. It can give me 16 bytes because of memory alignment and padding. This one can give me 16 bytes. That is a completely different class, but I'm just going to explain to you why that will be so in this class. Let me just explain. In the memory, you have something like this, right? You're having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that will be 12. Now, this struct should have 12 because the integer is going to give you 1, 2, 3, 4. So 4 bytes. 4 bytes were allocated for integer. Then the double will also will take 8 bytes, which will be 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. Right? So this one will be for the double 5, 6, 7, 8, 9, 10, 11, 12. So that will be 12 bytes. But because of memory alignment and padding, some processors access the memory in either 4 bytes or 8 bytes or 16 bytes, like that. So if you have a 64-bit system that is going to access the memory in 8-byte format, it means that there will be padding. It will access this, it will access the integer, it will access the entire 8 bytes. Then it will also allocate this double in 8 bytes. So the processor is accessing 8 bytes, 8 bytes, 8 bytes, like that. And if you have such a system, it means it's going to give us 16 bytes. 16 bytes instead of 12 bytes. Why? Because this, what the system will do is, because the processor is going to access that memory in 8 bytes, 8 bytes, and you have assigned the integer is only 4 bytes, it will pad this one, 1, 2, 3, 4. So it's going to give you 1, 2, 3, 4, 5, 6, 7, 8. So that is 8 bytes. So it's going to pad this. Then it will start this double, right? It will start it from here. So that will be 1, 2, 3, 4, 5, 6, 7, 8. That will now give us 12, 13, 14, 15, which is 0 to 15. So that is 16 bytes. So that is what the processor will do. The processor is going to access 8 bytes here, 8 bytes here. So because of that, when you run this struct, looking for the size of, which is the allocation that will be given for this data type, it will give you 16 bytes. Like on my own system, it will give you 16 bytes. So the reason is this. Why, if you run it on some system, it will give you 12 bytes. So if you are running it on your own and it's giving you 12 bytes, and you run it on another system, it's giving you 16 bytes, this is the reason. Now, if you don't want it to give you that padding from the very beginning of writing your code, it means you have to introduce a directive, a preprocessor directive, which is called pragma pack. So at this point here, before you start your program, you also include this pragma pack 1. So what this preprocessor directive is simply saying is that it's telling the CPU that I don't want padding. So when you are going to print out this data type for me, don't pad it. Give me the exact value of the space, which is what? 12 bytes. So if you introduce this, anytime you run your program and you have something like this, it will give you the exact byte. It won't give you in the multiple of 16, of 8, I mean. So that is what this is. So if the presidency wants to tell the senators not to pad, they have to tell them at the very beginning, I don't want padding in the budget. Those that understand what I've just said. So that is what happened. So let's go to code blocks and let me demonstrate the Sizeof operator for you to see what the output will be like for the different data types. This is our code block. We are going to have written the program. First, I declare the variable. The first one is A, second one is B, and the third one is C. So I want to find out the value of A, B, C. Then I also created another derived type here, which is what? Struct. So struct data. Then inside it, I'm having two variables, int x and double y, right? Now, I'm going to run this for you to see what the value of this will be. And then we are returning this. So I'm going to execute it. I told you, you can see this one, the first one gave me 4 bytes. So which means 4 bytes for integer on my system, 1 byte for character, and 8 bytes for double. And then I told you on my system is giving me 16 bytes. Then I said that if you don't want it to pad, I've explained to you on the board why it's giving me 16 bytes. If you don't want it to pad, then I'm going to add this preprocessor directive, which is what? Pragma pack 1. So with this, I'm going to re-execute this program again, and then you will see that the value, the size of struct data will be what? 12, because it's not going to pad. So I'm just going to run again. Now, if you look at it, you can see the first one is giving me byte, The second one is giving me 1 byte, 4 byte, 1 byte, 8 byte, and then the last one is giving me 12 byte. Because integer is what? Integer is 4 byte, double is 8 byte. So 8 plus 4 will give us 12 byte. But initially, when I didn't have this Pragma pack, it gave me 16 byte. I explained that to you on the board. So that is what I have to show you in this class. If you have come with me this far, do not forget to give me a thumbs up. And if you have not subscribed to my channel, please do so. And you can also follow me on my Facebook page. So till we see you in the next class. Bye-bye.